Today, we'll look at Chapter 5, Managing a Cisco Network. This is really more of the iOS, more commands. Being able to do things like to telnet to a remote system and manage it. Telnet's one of the things, and it talks about SSH. Telnet, non-secure, clear text passwords, clear text commands, clear text everything. SSH gives you a console connection, but it's a secure connection, and I think there's an SSH lab in there to do those with. And there's a Telnet lab. CDP is the other protocol that kind of hits hard on, and CDP is one that you need to know about because by default it's turned on. By default it's broadcast. By default it'll tell everything that's connected directly to you what you are, including the IP address of the system, what port is connected to. That's one of the demos, and that's that I want to do at the end here. And a couple of things about Telnet, how the Telnet passwords work or don't work as we do those things. So with that, the objectives of Chapter 5 objectives, Cisco router components, we're going to look at, again, the boot process. Boot process is a really big deal. The boot process is the thing that's going to allow you to recover passwords. I'll show you how to do that one also, if you'll remind me when we get into the demo portion of it. It's something that, oh golly, it's hard. It's not. It's really easy, but you got to do it a couple of times, and probably you can expect to be able to do that on the test in the lab portion of the test, and you'll probably be able to expect to have to do that before you can do the rest of the lab. So that's one you may want to really focus on, you know how to do that lab. The reason is it's one that's realistic. Somebody puts a password on a router and then they go away, get fired, forget it, whatever else. Now you're stuck unless you can recover that password. And it's just a matter of going through changing the boot process, and that's why knowing the boot process really is a big deal. The boot sequence, boot again, configuration register. You've heard the terms. Configuration register just simply tells the system where to look for particular components of the operating system, where to look for the iOS. The default says look for the iOS in flash memory. It says look for the configuration file in VRAM. If it doesn't have any of those things, if it doesn't have the configuration file, it goes into setup mode. If it doesn't have an iOS, it does this really cool thing, goes into ROM-MON mode. If you get a router into ROM-MON mode, that's not good. That means that your iOS is either missing or damaged. It means you really have a problem. I had a class one time, capstone class, getting ready to demonstrate their project that they had worked for like 5 weeks on. And they wanted to delete and change the startup config, which is erase startup. Instead, they typed erase flash. System says, are you sure? They said, sure, we're sure. So they erased the operating system from the router like an hour before they were supposed to do the demonstration. You can recover from that also. There are processes, I'm not have you do that, but there are processes. The way you do that, you go to our friend Google and how to recover from flash, and there are step-by-step instructions. When you get those step-by-step instructions, remember to put them in exactly as Cisco gives them to you, including case. I even use the same IP address. The other thing to remember is you got to have connectivity two ways. You have to have a console connection, and that's one of the things I'm going to do next week is to put up where you actually do a physical console connection. I'll demonstrate it here in a minute how to do it. A physical console connection, a physical NIC connection, because the console simply connects to the device. It becomes the keyboard and monitor on the device. That's what the console does, if you'll think of it that way. The NIC connection allows data to be transferred across the network. So if you have to do one of those kinds of recoveries, then you got to be able to have a connection via the console and via the NIC. Console so that you can set an IP address, because you don't have anything. The console so you can set an IP address on the device, and then give it the commands to do the transfers, and then the NIC connection so that you can actually transfer the data. Backing up and restoring the iOS. Backing up and restoring the iOS, same process for backing up and restoring the startup config. It's a little quicker to do that. The lab that you have, I think I have a TFTP lab in there also. The TFTP lab has a TFTP server on it. The little server that's in the lab has they've thought of lots of things in this piece of software, but it has a TFTP capability, a TFTP service that runs on it. So you would use that in those things. And I want to show you, and what I'll do is save from, we've got a telnet set up for the switch here in the back, go through the process from the console to how to actually save it, because additionally, to do these things, see, I'm doing the whole lecture here in the objectives. To do these things, you have to put a piece of software on your computer called the TFTP server, because by default, Windows machines don't support the TFTP protocol. There are a lot of them out there. They're free. You just run it, and it puts the information wherever the configuration is set up. Cisco Discovery Protocol, I talked about that a little bit earlier. I'll show you how that one works. Telnet, we'll look at that. Resolving host names. Resolving host names, you can either use a DNS server where you configure the router to use a DNS server, or you can create a host file just like you can on a Windows machine. You can create a host file that has the IP address that's associated with the name. DNS is typically the service that we associate with resolving host names or names, fully qualified domain names, to IP addresses. Or you can just simply use the IP address. If you fat finger a command, and if you haven't done that, you will type it in wrong. It goes through a churning process. What the router is trying to do is resolve that to a host name. The command to make that not happen at the config line is no space IP space domain dash lookup. So if you put that command in, it won't go through that churning process. If you type the command in wrong, it'll just say, hey, I don't understand that command. So that's something that can save you time, because it just, and it does it, and it does it, and it does it. Troubleshooting tools, these are the same troubleshooting tools that we've used forever, ping and trace route. It's not trace RT. In the Cisco system, you can use just the trace command or trace space route. Trace RT, trace route, and TRACERT is a Microsoft command. Trace is a Cisco command. Bootstrap, just like the boot process in a computer, right? We go through we start up, we have a bootstrap program that's called, that tells the system where to look for certain other components so that we can start the operating system. And the only thing we're doing is getting the operating system going. And if you start one, turn one off, turn one on, go to the command line, you get all those pound signs. That's decompressing the operating system. Most of them come compressed. Some of the older ones don't. They'll just load straight up without the pound signs. The pound signs is the decompressing, unzipping, decompressing the operating system. Post, the power on self-test, checks the basic functionality and hardware interfaces just like it does in a computer. There are certain things there like memory, processor. Actually, the processor doesn't yell a whole lot. ROM monitor mode, it says manufacturing, testing, and troubleshooting. Also should say, if you don't have an iOS, if something's wrong with your iOS, it's going to go into ROM mon mode. When I show you, and don't let me forget to show you how to do the password recovery, and then you can get that. I put the step-by-step instructions into the labs folder, so you can get that also. Because I'll go through it relatively quickly, because I want you to use the instructions as you do it. But we're going to go into ROM mon mode in order to change the location of where the system looks for things. So it's a big deal. Mini iOS loads the Cisco iOS into flash memory. Flash memory is where we would expect to find the iOS. It's called flash if you do a DIR a directory of flash, show flash. What it does is shows you the files that are in flash memory. RAM holds packet buffers, routing tables, the things that are in dynamic RAM, the things that the system wants right now. And the key to RAM is if you turn the router off, trip over the cable, whatever, the power goes off, all of that information goes away, just like in your computer. If you're typing a document and the power goes off, that information that's stored in RAM is gone. Same thing happens in a router. Where we want to store these things, it stores the running config. Where we want to store these things, for the running config or the startup config, the copy of that, we want it to be in non-volatile RAM, NVRAM. Non-volatile means when the power goes away, the information stays there. That stuff, when we talk about flash, is very much like the flash drives that you carry around. Do we need voltages on your flash drive? I certainly don't on mine because I don't have a little battery running around in my pocket. Non-volatile RAM. All of you use it. Flash memory. And it's a similar concept. The areas, it's just the areas where they are. So ROM starts and maintains the router just like ROM, read-only memory, starts and maintains the computer. Routers are just simply computers that have a specialized function. They do that. Flash memory holds the iOS, not erased when the router is reloaded. Reloaded being different from restoring or upgrading. If we copy a new iOS into the router, the first thing that the process is going to do is delete the existing iOS image. So it is important that you know how much memory you have and how much memory you have in flash and how big the file is that you're trying to put into the router. Because if the file's too big, then they're done that, and it's not something that you can't recover from. But if the image is too big and it erases the one that's there and the other one won't fit, when it gets done it just says, hey, file was too big and now you don't have an iOS on your router. Don't turn the power off. Hopefully what you've done before you started this is made a copy of the original iOS. If you have that copy, not a big deal. Now just copy that iOS into flash. And you have the original retained. But make a copy of those things, and that's what TFTP is all about, is copying those files back and forth between a workstation, a router, or a switch. NVRAM, non-volatile, holds the router and the switch configurations, not erased when the router is reloaded. You can erase this thing, startup config will erase it. It doesn't stop what's going on in the router at the time because all of the running information, all the information that the router is using is stored in memory. Unlike DOS, if you go back to an old DOS, a DOS 3.1.2 system, you can delete DOS. You can delete it off of the hard drive. As long as the router is running, it has certain commands that are stored in memory. You can keep running on the computer until you turn it off, unless you call a command that's not stored in memory, and then it tries to find it on the disk. But same thing here. You can erase the startup config. You can erase the iOS image. The router continues to run until you reload it, restart it, turn the power off, because all of the information that it needs is in RAM. Configuration register tells the system where to find the iOS. And we're only looking for two things, aren't we? The iOS and the startup config. So it tells the system where to find those things. Now, it could be the default place that we're going to look for the iOS is in flash. We could store it on a TFTP server. So it doesn't have to actually be physically stored on the router itself. We could be running a TFTP server in here, and when it starts up, the configuration register says, oh, go to the TFTP server and get this particular file and load it into memory. So they don't have to absolutely be stored there. Kind of a security issue, can be a security issue. last year, the network administrator for the city of San Francisco got arrested by the city of San Francisco because he wouldn't give them the passwords. Now, he'd been the network administrator for many years and nobody ever asked him for the passwords. He had the network held hostage because he didn't have the operating systems and the configuration files stored on the physical devices. The answer would be, and when we see the recovered password, he didn't give you don't give you the password, big deal. Well, as long as we can plug a console cable into it, we're ready. We're done. We can change. If we don't recover it, password recover, we actually change the password. But if none of that's stored on the router, whole different situation. You reload the routers. He's got the images someplace else. Turn the TFTP server off. Go to get it from a TFTP server that's not there. It just goes into ROM-on mode, and you're done until you can get an iOS and a configuration on there. And these would not be 3 or 4 line configurations, the kind of things that we're doing, maybe 20 or 30 lines. These would be hundreds of lines of configuration that would be there. So it controls those things. So the sequence, again, the router performs post. The post looks for and loads the iOS. The default configuration, 2102, is going to be the default configuration register. Will tell it to look for the iOS in flash memory and look for the configuration, the startup configuration file in NVRAM. So the iOS software looks for a valid configuration file. The configuration file again in NVRAM. Startup config from NVRAM is loaded. This is an out-of-focus picture where these things come from. So the test the router power and self-test, ROM runs post, performs the post. That's controlled by ROM. Step 2, execute the bootstrap loader. Bootstrap loader, load the bootstrap. That's going to be from ROM. Then the bootstrap loader looks for the configuration register. The configuration register is stored in NVRAM. So the config register tells it where to look for, and the default is flash for the Cisco operating system, the Cisco iOS. Can be stored in flash, can be stored on a TFTP server. Then it looks for the configuration file. NVRAM is the first place it's going to look. TFTP server can be stored there. If it doesn't find a configuration file, a startup config, then it goes to the console, it goes into setup mode. What will happen here, it says it can be either, if it doesn't find these things, it actually does a broadcast looking for them, looking for a TFTP server. If it finds it, it'll load it from that. That's a default. You typically don't see that. You just see it in here in the configuration file. It just goes into setup mode. It has checked to see if there's a TFTP server that you forgot to tell it about before it does those things. Again, another picture here. What we're going to do, checks the configuration, the order sequence, checks the configuration register, parses configuration for the boot system command, defaults to the first file in flash memory. If you have a lot of memory and you have more than one iOS stored on the router, it's going to load the first binary file, the first iOS in the list. Attempts to boot from a network server, defaults to the first file in flash. If it doesn't have that, then it attempts the network server to boot helper image. And if it doesn't find any of these things, it goes into ROM-on mode. And again, if you get this ROM-on cursor, ROM-on with a greater than sign, that's not good. Generally, that's not good. The default would be we had a damaged iOS. If somebody had changed the configuration register, that could be the issue also. So you need to look at the configuration register to see if it's right. If it is, then you have a problem with the iOS. You've got to go back and do those things. And again, just another picture. Flash memory is loaded into RAM. Cisco iOS, show flash. Show flash is the way that we see the name of it. You can also get it from show version. Remember, show version shows you a lot of information, including at the end the default configuration register. When you get ready to make changes to the configuration register, write down the one that you started with so that you know what to put back when you get done. because that's going to be the thing that tells it to look for the iOS in Flash and look for the configuration file in VRAM. And after we change it, and I'll show you how to do that here in just a minute. So show flash is going to show you those things. Show flash gives you a list. Show version, where was I going to show? With the show version command, also tells you the last place it booted from. What file did it use? So if you're booting from a TFTP server, you can see that, and you can use the show version. If it's different, you say, oh yeah, that's a TFTP server. That's what it's supposed to be. Configuration register, 16-bit software written into NVRAM, loads from flash memory and looks for the startup config file. The registers are 16 bits read 0 to 15. What it really is hexadecimal numbers. Register 2102, when we do that thing, the bit number 0, 1, 2, 3 on to 15, which gives us a 15-bit, a 16-bit, a 16-bit register. But, one more time here, when we go through these things, the 2, and this is off, not exactly lined up, using our placeholders, 0, 1, 2, 4, the first one here turns on the 2-bit. When we go to the next set of 4 binary numbers, 0 to 15, all zeros turns on all the 0, so we get a 0-bit. To go to the next one, even though it's under the 8-bit, that's the one placeholder value in the hexadecimal system. So it's a 1, and then in the last one, even though it's under the 13-bit, that's the 1, 2. So the register is 2102, and this is going to be the default in the 2600s at least. 2102 tells the system to look in Flash for the iOS and to look in VRAM for the startup config. The bit values, if you want to change these things, and this table's in the book, so if you want to study it, take a look at it. It tells you where these things are, what the bit values. And these are, back to the one before, these are the bit values that we had, and that's why the bit value order the bit value, the 0 through 15, when they talk about, that's not where I want to go. The bit value are these here, so what are the bit values going to be for the different things that you may want to change in the configuration register. More boot fill, ROM mod mode to boot fill 0001, boot image from ROM 02 through F specifies a default boot file name. 2102 through 210F tells the router to use the boot commands specified in NVRAM. Show version, and I think that you've already done this in a lab, but show version is going to show us what's running. This says that C2600, we got a 2600, the version 12.03 T3. If you look in the cheat sheets folder, there is a document in there that explains what each element of the file name represents. You may want to take a look at that. Configuration register down here, 0x, tells us it's a hexadecimal number, 2102, and so that's going to be the default, at least in the 2600. Most of the things, the ones that we're going to be using will be the default. Force the system into ROM mod mode, select the boot source and the default boot file name, enable or disable the break function. And again, this is what I want to demonstrate, set the console terminal baud rate. The console terminal baud rate, when we go into the terminal, the things that start up there, that's the 9600, 8, none, 1, none are the defaults. Load the operating system, enable booting from a TFTP server, you can do all of those things. Config register 0 by 0101. Control Z, when you get through with configuring things, you can either use the Control Z command, which will take you back to the enable mode, or you can end. Exit takes you back one level. So if we were in an interface configuration mode. When we hit exit, we would go back to configuration mode. Show version, configuration register 02102 will be 020. And this is obviously you were routed in, we're booted into, we knew the password, we could get into configuration mode, we changed the register here. Tells us what it will be the next time we reload. If we type the reload command, this will be the configuration register that it tries to use. Recovering passwords, I'll go through this quickly. Again, this is one I want to demonstrate. You interrupt the boot sequence, control break within the first, I think they usually say 30 seconds, 15 seconds of the system starting up. What you want to do is control break while the operating system's still loaded. Change the configuration register to 02142. Restart it, reload the router. When it comes up, what this tells it to do is load the operating system from flash, but don't load the startup config file. So if somebody's put a password in there that we don't know and it doesn't get loaded, and it doesn't know that it's got a startup config file, it just simply goes into setup mode. And we just say new from setup mode. Go into, use the enable command, go to exec mode, and then copy the startup config to running config. Use the enable, go to config mode, enable secret, whatever we want the password to be, and we just changed the password that we didn't know. We can see the hash. You can try to crack it. You can put it in a password cracker using a hash. It's usually easier just to change the password to something that you know, unless you're absolutely dedicated to figure out what it is. So privilege mode, copy the startup config to running config, change the password, reset the configuration register to the default. That's why you needed to have recorded the default, because when you get done with this, you want to set it back so that it's going to start from flash and from the startup config in NVRAM. So put it back to the original and then reload the router, and then you've got your new password on the system. Control break key, that's the one again, recovering passwords. I'm going to do that one. I'm going to show you that one here in just a minute. Backing up and restoring. Before you upgrade, copy the existing iOS to the TFTP host, because what if the new one doesn't work? What if it doesn't fit? The thing we talked about earlier. What if you delete the existing operating system and, oh golly, the new one doesn't fit, it's too big. You want to put the original back. Copy it. And it's just a matter of using the copy command. I'll show you that again. I'm just going to copy a config file. Same process for the operating system, except that the file name is going to be a lot longer. Show flash. When we show flash, it tells us the name of the file that we want to save. And the command that we would use through the console is copy flash space TFTP. Then it'll go through a series of questions like, what's the IP address of your TFTP server? What's the name of the file that you want to copy? When you get through with that, what do you want to name it at the destination? So those things are available. Backing up the iOS. And here's one that really is a big deal. Ping the TFTP server before you try to start this thing, because if you can't ping it, I guarantee you that it ain't going to copy to it. Be sure you can communicate. That's back to the issue. You've got to have two types of communication, the console communication, the keyboard and monitor connected to the device, and console or telnet session. And then a NIC communication via an IP address to actually transfer the data. Copy flash TFTP or copy startup TFTP, good connectivity, ping the thing. Backing up, verify the current configuration, show run, show start, verify the available memory, copy run, running config into NVRAM, copy run start. When you make changes, if the changes work, copy run start. Two-sided sword here. If you make a change to the router and it really messes things up, oh man, it really messes things up. If you haven't copied the running configuration, the startup configuration, just turn it off and turn it back on. Then it will load the existing startup config. It doesn't change until you take an action to copy what's in memory into NVRAM. So if you do something and mess it up, big thing, I did that one time. I was working at home from a router with a TELNET session, and I changed the IP address on the wrong interface, the one I was connected to. Well, turn me off immediately, obviously, because I was now connected to the wrong IP address and one that didn't NAT. So called up and said, hey, how about go and turn the router back off and on? When it reloaded, I had the old configurations there. Now, if you've done a bunch of things that worked and haven't saved them, they're going to be gone also. So this is a command that if you don't do it, you didn't save it. If you turn the router off, it's gone. Because when you do the configurations, they only go into dynamic RAM. They go into NVRAM startup config whenever you tell them to go into startup config. Copy run TFTP will copy the running configuration to a TFTP server. When you want to get it back, you copy TFTP to whatever. If we had the startup config and we wanted to restore the startup config, we would copy TFTP, copy source destination is the way these things go. So if we wanted to get it from a TFTP server, copy TFTP startup. We would restore the startup config. I put this one in because a couple of things happen. And basically, if you look at this thing, it says copy TFTP run, goes this direction, it says merge. If we copy running to startup, it changes it. So anytime that we copy something into the startup config file, it deletes the existing file and puts the new information in. Anytime we copy something into the running configuration file, it merges it. That means that it only changes the things that are in the existing one. If something is unchanged, the example here would be if we have one that maybe is a host name Jose or whatever, host name San Jose, how's that? And it had an IP address on a interface Ethernet 0.1 or fast Ethernet 0 on 192.168.3.1, and in the new configuration file, we only had an IP address of that fast Ethernet interface 192.168.10.1. When we copied it up, it would change the IP address of the interface, but it would leave the host name intact because the host name wasn't part of that file. When we merge them, it only makes changes to things that are stored in the source file. So if you do that and say, oh, it didn't change everything, yes, it didn't change everything because it only changed what it had. Restoring the configuration, changes made to TFTP host need to be copied. Copy TFTP run or copy TFTP start. Again, if we copy TFTP run, it's going to merge the configurations. If we copy TFTP start, it's going to replace the entire file. And if you wanted to replace everything, what I would do anyway is copy TFTP start, reload the router, restart the router. It doesn't really take that long for them to restart typically. Firewalls may take a while. I said typically, depends on how big the configuration files are. Erase startup config makes it go away. Erase startup config, when the router reboots, you go into setup mode because when it goes through the process that we talked about earlier, you can't find one, and then it says, okay, I want to do that. CDP, Cisco Discovery Protocol, is a proprietary protocol, and it is turned on by default, which means that it's telling everything that's directly connected to it who it is, what its particulars are. And again, this is one I want to show you a little bit about. The hardware information, protocol information, we can find out what the IP address is of the other system. It's a layer 2 protocol. So it can also be used in troubleshooting. If we have a layer 2 issue, then we're not going to get any CDP information. If we have a layer 1 problem, we're going to have no information. But it's a layer 2 protocol and useful in troubleshooting and documenting the network, and that's one of the labs that I have for you to do. CDP timers, how often the packets are transmitted to all the active interfaces. You can change these the whole time. It shows these down here at the bottom. The whole time is how long it'll keep that information. in memory. The CDP, the default is to broadcast every 60 seconds, and the whole time's 180 seconds. You're going to find 3 times the timer time is that kind of a theme that goes through Cisco products. Whole time 3 times whatever the default broadcast time is. You can change these timers if you don't want it broadcasting. You can turn it off. You can turn it off for the whole router, no CDP run, or you can turn it off interface at a time. Interface at a time is probably what you want to do. You might want it inside your network so that you can use it for troubleshooting. You can use it to find out what's going on. Also, I think you'll find that if you have voice over IP phones, you have to have this because VoIP uses this particular protocol. So if you're using VoIP, you're probably going to have it turned on, but you may not want it to, for instance, broadcast to your ISP so that they can see what's going on. You can then no CDP enable. You can enable, disable with the no enable command on an individual interface. You can turn it off on the entire router with the no CDP run. And if it's not on and you need it on, use the CDP run command. Show CDP neighbors and show CDP neighbor detail, things I want to show you. Show CDP neighbor will gives you a nice little matrix about what's attached to you, what ports you're using, what port you're connected to it on, what port it's using, what type of operating system it is. Show CDP neighbor detail will give you the IP address that it's running on, so that when you do your lab CDP neighbor, you have to find out what the neighbor is, what they are, what they're connected on, what the IP address is. Telnet to it and keep working your way down the line as you do these things. The traffic, CDP packets and sent errors with CDP, you can show the CDP traffic. These will be troubleshooting. Timer and hold time for each interface, show CDP interface. More information that you can find out about this thing. This is kind of a little picture here. If we wanted to find out what was going on here between Vail and Keystone, console connection to Vail, we would go into Vail, show CDP neighbors. It would tell us that we have a switch connected to us and a router connected to us, what iOS each of those is running. If we then wanted to find out what was connected to Keystone, we'd have to use the show CDP neighbors detail on Vail to find out what the IP address is. Telnet to Keystone and use the CDP neighbor command again. Telnet, VTY passwords, and I think you've already kind of done a little bit of that, must be set on routers. If you don't, and I want to go through a couple of things that may happen to you with Telnet passwords when we do the little demos here in a minute, but you have to configure a password in order to Telnet, and you have to use the login command. The default for VTY is you have the login command but no password. If you Telnet to it, just nothing happens. If you configure the password and don't configure the login command, it says that the password's set but there's no login. If you do login without a password, you'll get a bunch of error messages that says, okay, you did this, but you got to set a password. Doesn't matter which order you do them in. If you use the no login command, no passwords are required. If once you Telnet to it, you want to go into enable mode, you have to have an enable password. It will not allow you to do that until you set the enable password. So you need to set an enable secret password if you want to truly manage it remotely. So config T-line VTY04, login, password Cisco, trying 172 user access. It'll ask you for the password. We'll get into here, and then if we try to go in enable mode, it'll say that you don't have an enable password. You have to have one before it will allow you to do that remotely. Those I said I want to go through them. VTY password is in user mode. not enable mode with no enable or enable secret password. The following happens, no password set, set you right back, won't let you go into enable mode. If you, the Control-Shift-6, Control-C is the break sequence for DOS, something's happening you don't like. Control-Shift-6, release that, and then the X command is what Cisco uses. Control-Shift-6 and X, if you're in TELNET, will bring you back from the TELNET session. And I think there's a couple of exercises to do that. Once you get back, you've TELNETed, you want to go back, Control-Shift-6 and then X, you'll come back to the original show sessions. If you're on a machine, TELNETed to a machine, you want to see who's TELNETed to you, use the show sessions command. So show sessions who's to you, Control-Shift-6X gets you out of a TELNET session, or you can log out of it also. So you show users, so show sessions, that's hard to say. Show sessions, once we get back here, will tell us what the TELNET sessions are, because this doesn't log us out, it just simply brings us back to where we started from. Show users will show us who is actually connected to the system. You can exit, disconnect, log out to get off of the TELNET session. Host names, you can either do a host table or a DNS server. There are situations that you need these things named, not always, but you can specify a DNS server so that it does the lookups from the DNS server, or you can create a host table which has a listing of all the names that you're going to use as well as the IP addresses that it does the lookups there. Host names, IP host name, IP host router B172, IP host switch, on and on. Show host, as we go through those things, the default port numbers are 23. Control-Shift-6 to get back to the systems. The TELNET default port's 23. DNS to resolve, you just simply set it to a DNS server with those commands. Ping, trace are the commands. Ping, trace are commands that you've been using hopefully for a long time to discover connectivity. Remember, ping and trace check connectivity at layer 3. Doesn't mean that you can work at the upper layers. If you have other services, you can telnet to those services. If we have an HTTP server, you can telnet to port 80. You can telnet to port 25. That checks the whole stack. Telnet works at the application layer, not just the layer 3. The first place you want to check is layer 3, and if that doesn't work, work on up. Again, trace is the Cisco command. It's actually trace space route, but it's unique, so you only have to use trace and not trace RT. Trace RT is going to tell you it's a bad command. No big deal, just a bad command. Go back and use trace. And if you've used the no IP domain lookup, it doesn't try to resolve it in DNS. So, go through those things. You have a number of labs to do. What I want to do is take a break here, and then when we come back, I want to demonstrate a couple things in Packet Tracer as well as in a console command before you get involved in the labs. Are there questions at this point? The only way to learn these commands, how to use these commands, is to actually use the commands. So that's where we're going to go. Hopefully this class is a little bit of lecture, a lot of lab. What I'll look at here is TELNET and a couple things in TELNET and CDP and then password reset. So if we want to TELNET, and I have already configured an IP address on these things, go to the command prompt and just telnet 192.168.1.1. And it said that the connection is closed by the foreign host because I have not done the required configurations yet. So now let's go with our console with our terminal port, console port. Oh, I guess if I plugged in a console cable, it probably would work better, huh?
That would help.
Let's try the console again. Ah, much better. In order to, and I'll show the running configuration here, lines ETY04 login. So what I have is no password configured. You can't telnet into the system until you telnet. And the commands will go into the config T, all right, line VTY04, and we'll use a really complex password. Actually, let me try the login. Give the login command, and what I wanted to show you, you get the error messages. They say, login disabled on line 66 until a password is set. If I did the password first and then gave the login command, I wouldn't get those error messages. So that is a safeguard. So if you use the login command and not a password. But let's try something else first, because when I get the passwords on, I want to show you that and I have to go back. Let's try no login, which intuitively you would say means that you can't log in, right? Think that's what it means? Let's go back to this thing. And now I'm logged in. What no login means is you're not required to log in. Okay? So by giving the no login command, anybody can connect via telnet to your system. Let's try the enable command. No password set. So the things that we talked about in the lecture, if you don't have a password set for enable, it just says you can't get there. So you have to have configured the enable password before it'll let you get into those modes remotely. Let's go back to, and to simplify, instead of swapping back and forth, I'm just going to open the CLI here on this thing.
Are you in a particular lab, Mr. Cole?
No, I'm doing a demo. I'm not in a particular lab. I'm on the config line. Instead of no login, I can do the login. Gives me the same errors, and then put the password. So we have a password on this thing, and again, we can do the end command, Control Z. Go back to the PC here, log out, and let's telnet to it, and now asks for the password, and you notice until I logged out, that password wasn't enforced. When I try to log back in, I can now have to give the password. Everybody uses the same password for this particular variation. So you only give the telnet password to the users that you want. We'll learn how to control that more as we go through the system. I still can't get into enable mode though, can I? No password set. Let's go back to the router. Big T, enable, secret. Okay, now then, I should be able to use the password and get in there. So the password sequence, the no login on telnet says you don't have to log in. If I use the default, I can't telnet. I have to go in and give the login command as well as a password. I can't get into enable mode until I put an enable password, and I use the enable secret password in order to do that. Telnet, really wonderful thing for us to use. The other thing that I wanted to look at, what we said, Telnet, CDP, and what was the other one? TFTP. I'll look at TFTP as the last one. I'm going to do that on an actual one. The CDP, if we went into this thing, back to the terminal, to the console connection, Control Z gets us back, show, because I'm on the router now, remember, CDP, neighbors, it says that I'm connected to a switch down here. The system, the local interface is the interface on my device. So the local interface is the interface on the router. Fast Ethernet 00. And it's connected, the whole time's 120. That's how much time is left. The total whole time, 120, if we got in at the beginning, the whole time would be 180. That's how much longer it's going to keep this information. Capability, S says it's a switch. It'll be an R and S. It could be an R and an S. Some switches, some routers, have switching modules. So if you have a router with a switching module in it, it'll say R and S, switch and router S and R. It's a 2960, and I'm connected to Fast Ethernet 01 on it. The port ID may be poorly named, but the port ID is the port that you're connected to on the remote device. You have a lab to discover the topology on a network that is not here. In order to do that, you're going to have to go in here. Let me get this out of the way and use this little cloud feature. Bring the cloud feature back over. When we go in here, it says incoming is the default. We're going to create an outgoing connection. And the outgoing connection, and I've already done this once, 1060, you might want to write this one down, 10.60.66.253. It's actually in the lab, but write it down anyway. When you start this up, it's going to say localhost. Well, it's not on your machine, it's on my machine. 10.60.66.253, local here, you're going to need to do it here. I don't have ports to connect from the internet. So you have to do this lab in the building. So you don't have to do it in this room, but you have to do it in the building. 10.60.66.253, the default port's 38,000. Peer network name, just put your name in here, and that will give you a name at the other end. When you connect, it'll just tell your name will be the connection. The password is, cleverly, Cisco, all lowercase. So I fill all that in, connect. This thing down here should turn blue. So now we have a blue cloud. In order to finish the connection, I'm going to go down to the end devices and drag myself up a computer. Then I'm going to connect to a switch remotely. So I'm going to go in here and connect a PC to a switch. I use a straight through cable, right? So I'm going to go down here and pick my straight through, go for my Fast Ethernet, click on the cloud, and I get a listing of ports that are available on the remote switch. Okay? So I'm going to connect here. Just any of them will work. So start it up immediately. I think that I put port fast on that one. IP config. I guess if I spell config right, it would work better, huh? I'll have an address. If I do a renew, because these things are set up as the default for static. What's kind of interesting, if you'll tell it to renew, it'll go get an IP address. So I have an IP address. I know what the default gateway is, 192.5.5.1. It's there. You don't have to worry about writing that down. So the next thing that I want to do is to figure out these devices. Well, to get to the first device, I know how to get there. It's the default gateway. So if I telnet to 192.168.5, not 192.168, 192.168.5.5.1, password is password. I'm on Lab A. If I want to see what's connected to Lab A, what command do I use? Show. What's going to show me all the devices that are connected at layer 2? Show CDP neighbor, which works at user mode also. Show CDP neighbors. It says that switch 1's connected on Fast Ethernet 00, Lab B, serial 1 to 0. The capability of the switch is switch. The capability of the router is a router. It's a 2950 switch and a 2600 router. So what you're going to do is draw this topology in packet tracer. And what you're going to submit when you get done is a packet tracer file. So now you know that the first device is Lab A, a router, right? So you would drag a router up into packet tracer. And you know that it's connected on its fast Ethernet 00, and you have to put the modules in, the serial modules in, because the 2600s don't have serial modules. It's a 2600 router. And it's connected on serial 10 to a 2600 on its 10. Now, how do I get to the next device? Huh? I would use TELNET. But I don't know what I'm telnetting to, do I? So how am I going to find the IP address? We're going to use the detail command, which says that Lab B is 201.100.11.2. So I should be able to telnet to 201.100.11.2. Password is password. Go through the same show CDP neighbors information again. And now we can find the IP address that we just came from, because you can't see the IP address until you can get into the enable mode. If you want to get, if you want to look in enable modes, show IP interface brief or things like that, the enable password is secret, so you can't see those things. Please don't change any of the configurations. I can fix that. Just for you, I can fix that. Okay. So that you can't get in. Sounds good. But just go through these things. So if we show CDP neighbors, again, now we have a switch again, switch 3, 2950s on fast Ethernet 01, Lab A, the one we just came from, serial 10. And it is a 2600 10 to 10, and Lab C, we're connected from serial 11 to serial 11 on the other device. Go through that until you run out of devices. Once you get to the end and there's nothing new connected, you're at the end of the topology. But that's the Discover Topology Lab, which is the last one I think that I've given you. Again, you will have to do it here because you have to connect to a remote device. Or you could do it from a virtual machine if you put packet tracer on the virtual machine. Yeah, because virtual machines are on the internal network, so they'd be able to resolve the private IP addresses or get to the private IP addresses. The last thing that I wanted to look at is TFTP. And on this machine, I hope, I have a TFTP server, TFTP desktop. And again, you can get a lot of these things. This says, am I using this for personal use? Yes, and it lets me do it. When you configure a TFTP server, you don't, when you copy something to a TFTP server, you don't get an option as to where to send things like you would with FTP, where you can see the directory structure. You configure a TFTP server before you start. I will go to Server Properties, General, the default directory /TFTP desktop is where all of the files are going to go. That's where it's going to send things, and when you copy from the TFTP, that's where it's going to look for things. So you can start a directory, and that's about all you have to do. The other thing that you do need to know is if you change the IP address of the device, you have to restart the TFTP server because it reads the IP address when it starts. Now I'm going to go to 10.60.211.254. So based on the little, let's test everything out, do a command prompt, I should ping 10.60.211.254 to be sure that I can connect to it, and I'll get a timeout. Okay, now it's answering me. You will also find, as you go through the Cisco world, that you're probably on the first ping is going to be a no the first time through. If I do this again, and it's tied up in trying to do the ARPs, the amount of time it takes to do the ARPs. And if I do it again, I'm okay. I get all of them. So if you get a Cisco device, the first time it says no, that's normal. That's standard. So now I want to telnet to this guy, because I'm not going to run a console cable back there. We obviously could do that, but I know the address in telnet. Spell telnet right. 10.60.211.254. Password is something, if I can remember it. Okay, I'm on the switch. Same commands we would use on the switch. That's kind of the neat thing about the Cisco IOS. The commands are very, very, very similar on all of the devices. In order to do this, I need to go into enable mode to copy these things. And what I want to do is go back to my default directory, which was E:, I'm on E: TFTP desktop. I'm going to delete this because that's going to be the same one. Now, in order to get the startup config, I'm going to copy start TFTP. The address or name of the remote host, that's my machine. The remote host is where the TFTP server is, and since I don't know what it is, I'm going to have to figure it out. And it's 10.60.211.177. 10.60.211.177. The destination file name, switch config, and I'll just leave that to default. If you don't want to change the things, whatever the default is, whatever it's going to assign, is in the square brackets. If that's right, just use the enter key. If you want to change it, type whatever you want to change it, and I'll just use that one. And it's done, by the way. The two little exclamation points here means it's good. If you get anything other than exclamation points, you've got an issue. Exclamation points is when it copies that information. Copied, it says 4495 bytes copied in 0.056 seconds. So it has done that. If we wanted to copy the iOS, we would copy flash TFTP. I'm not going to do that. It takes longer to do that, although it probably would be a good idea to do that. Switches kind of get a little bit weird sometimes. Copy flash : to get the directory when we do those things. But that's the way that the connectivity. I said you have to have a console cable. We have to have some sort of connectivity. Since it's already had an IP address, I can telnet to it instead of connecting a console cable. If I didn't have an IP address, I would need a console cable going into the console port, RS-232 from the computer to the console port of the system. Questions? Oh yeah, reset password. That was the other one I was going to show you how to do. I'll tell you what we'll do, just to show you that it really does kind of sort of work. James, come up here just a second. Come on. Okay, he's put a password on it. What do we need to get to save his password so that I can't use it? I don't know. How about copy, run? And notice I did the tab and it did that. Start, if I can spell start. Yeah. Copy their startup config, yes. Okay, so let's reload just to see if it works. I know what the old password was, so I'll try it when I get there. Reloading, self-decompressing the image. That's what the pound signs are all about, decompressing the image. So we go into this thing, enable the password. I don't know the password, okay? So what I'm going to do is in the terminal here, and what I'm going to do, because we would physically do this, is get to the physical part of the router, turn the router off, turn the router on, go back to my PC, control break as it starts up. I'm now in RUMMON mode. That's what ROMMON looks like. If you can see it, it just says ROMMON/1, step 1. Now, back in the lecture, we said we got to change the configuration register. How would I find out what command you needed to change the configuration register here? 2142. What's the command to do that? That's what it is. Config T, there is no config T. We're in ROMMON mode. We have we have ROM commands, and this is where I want it to go. So, like everything else, I use the handy-dandy question mark. You notice ROMMON went to 2, which means I'm on my second command. So, the command, there's really kind of a short list based on what you've been seeing, huh? Confreg is the command. So I'm going to do confreg 0, and what was it, 2142?
Yep.
2142. And then we'll use the reset command. Self-decompressing looks familiar, huh? What I have done with that 2142 is that don't use the startup config file because that's where the password's stored. And it says now, continue with configuration dialog. I say no. No. And now I can go into enable mode because it doesn't know what the password is. Okay, now I can copy, start, run, copy the startup configuration file into the running config because I didn't have anything in the running config or in the startup config, so I don't have anything in the running config now. Show, run, and there's that really cool hash for the password that he put in. So how are we going to make that go away? We'll just go down here and go in config T, enable secret, Control Z, copy, run, start, reload, just to prove that I did it. All that work he went to thinking up that really cool password. And we did away with it in how long? Under 2 minutes. Under a minute, probably. You don't think I did away with it?
Oh, no. The time.
Huh? Did I? 6 bytes copied. It didn't keep it, did it? Did I not save it? Oh, I think that you're right. So let's enable secret. I got back here. So I'm going to copy, run, start, right? Let's see if, okay. I'm using my password now because I got back into enable mode after I did this. So if you want to get out of enable mode, disable will get you out of that to try things out before you go any farther. So we should have a startup configuration file, and now I do have one. Oh, you know why it did that? What didn't I do? I know what I didn't do, and you just let me know. What's the last step that we have to do? You have to put it back to where it uses the configuration register. What was it when we started with? We didn't do a show version command, did we? Fortunately, I know it's 2102. So we'll go to config T, and using my handy tab key, config-register 0 by 2102, Control Z, and now if we do the reload, and reload reloads the system, restarts the system. Now it should come up with, we hope at least, the configuration file, right? That it's going to use with my handy-dandy new password. So you want to try to get in, James, or should I just try mine? Let's just try mine. Let's see if it worked. I'm in. What's the trick to this? What if this router were a physical router sitting over in the NOC? Could I do this? unless I had a really long console cable and had a key to get in there. You have to have physical access to the router. Yes, it's easy to do. Yeah, you've got a lab to do it. Expect to have to do this on the lab portion of your tests, because it's something that you may need to do. Somebody sets a password, forgets the password, types it wrong, got the caps lock on, whatever else. When they do the password, you may have to actually recover these things. Doesn't take long. Got to have a console connection, and that's about it. We didn't even need an IP address for this one, did we? For real. All we needed was to be able to get there with the console. So I think those are the three things that we talked about for the demo, weren't they? You've got labs to do on all those things. I want to go through the steps quickly before you do the labs themselves, particularly on how you're going to connect to get to that CDP neighbor. There's a CDP neighbor lab, and then there's a discover topology, where you're going to use CDP, show CDP neighbor detail, and the telnet in order to get there. Keep in mind that everybody can't do the lab at the same time because there's only 5 telnet connections, so don't everybody try to do that one. It's 0 through 4, right? 5 telnet connections. Also keep in mind that the telnet timeout is 10 minutes. So if you dawdle, you may get thrown out if it's inactive for 10 minutes. So those things, if those things happen to you, yeah, they may happen to you. Sorry. Questions?